That's a good question, isn't it? What is light?
Isn't it an element?
Light is brightness, I guess.
We have auras.
We all have auras.
Which are light?
Yes, they are.
It lights up the room. It makes it not dark.
What's the difference between blue light and red light?
The colour.
It goes in your eyes and then you see stuff.
They range from white to red to orange to green. It's like the chakras of your body.
Can you see my aura?
No, not particularly right now.
Is it too bright out?
It's very sunny out here today.
Does that make it harder to see someone's aura?
Not necessarily.
If I was to explain it to a blind person, right,
Yeah.
it would be the difference. You see nothing whatsoever as a blind person, whereas I see things in front of me.
To be fair, the question of what light is not an easy one. For centuries, the greatest minds in science debated this issue. In the late 1600s, Newton proposed that light was a stream of particles, or corpuscles. He proposed this in his treatise Optics. But at the same time, a Dutch physicist named Huygens proposed that light was a wave. And this debate raged on until it was settled by the experiment I've recreated today, Thomas Young's double slit experiment. To make sure I got the experiment right, I went to the original source. With the help of Brady Heron, I managed to get into the vault underneath the Royal Society in London. There I found Thomas Young's handwritten notes from 1803.
I brought into the sunbeam a slip of a card, about 1/30th of an inch
in breadth,
and observed its shadow, either on the wall or on other cards held at different distances. Besides the fringes of colors on each side of the shadow itself was divided by similar parallel fringes.
smaller dimensions. Wow.
This is an experiment so simple that you could make it at home, and yet so fiddly that I have never seen it before done with sunlight. I was thinking about doing it in a box, like a fridge box.
And you could take it out on the street.
Taking it out on the street. Could I possibly interview you guys for about a minute? We're doing a science experiment. What I have here is an empty box. And this is a little eyepiece where we can look in, and this is a hole. And I'm gonna place this slide above that hole. And if you look closely, you'll see that there's two openings. Very narrow openings side by side. It's a double slit. Now before we have a look, we need to tilt it towards the sun a little bit. So we want the sun to hit this double slit directly. What are we gonna see on the bottom
Well,
of
the
the
obvious
box?
thing you think you're going to see is you're going to see two lines.
Two lines on the bottom of the box. Two bright bands.
Two little lines.
Yeah.
I think it'll be one line instead of two.
I could expect to see the whole box lit up.
It'll probably be a kaleidoscope of some sort.
A bunch of colors.
Probably, yeah.
Rainbow, different colours.
There, have a look. You expected to see kind of one line. Is that what you see?
No.
I see dots.
How many?
It's one circle.
Well, there's one in the middle strongest, two either side.
The two on the outside are multicolored, and the one in the middle is just white.
It's kind of a rainbow.
The rainbow of colour as well.
Quite a few colours and lots of little dots.
Like there are more dots appearing.
I think I can even see more dots spreading along. Yeah, that's amazing. Yeah, I can see tons of dots now. Not tons, but I can see dots spreading across that way.
Either side.
Yeah, definitely.
Isn't that amazing?
Yeah, that's incredible. And that's just nothing else apart from
Two slits.
two slits. I can't believe- That's incredible.
But all we're doing is we're putting a light through two very narrow slits side by side. So how does this make any sense?
There's some kind of principle involved in it that the average person is not familiar with. That's the only explanation.
No, I'm really confused by it, but I'd like to find out why.
People were debating, is light a wave or is it made of particles?
So what causes that?
Well, if light were behaving as particles, you would expect them to go through each slit and just produce a bright spot underneath. So we would see two bright spots on the bottom of the box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light. When the light from one slit met up, peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light cancelling itself out.
This is basically the same as like having 2 drops of water fall in a swimming pool.
That's right.
Get exactly the same
and then
pattern.
they go and overlap. As this ripple overlaps with those ripples,
Yeah.
down the bottom, you get a series of, you get like a bright spot, and then a dark spot, and then a bright spot, then a dark spot, then a bright spot. Now there's a slight complication, which is that sunlight is composed of many different colors, and they have different wavelengths. So obviously they're going to meet up at slightly different points. And that's what caused the rainbowing effects as we go further from the central maximum. You saw the ones to the right were slightly colored.
Yeah, it's
that's because
burgundy.
the reds are going to meet up at different places than the blues.
And that's all that makes the colour differences, is different wavelengths.
Exactly.
That's amazing.
So the difference between
So,
red and blue,
that red bin over there and the green part is just, I'm seeing
It's a
that and it's
different-
just different
different
wavelengths. And that's how we bring in all these beautiful colours all around us.
Exactly.
That's amazing. I'm amazed. Oh, good on you, thanks, Beck.
Hey, thank you.
I have been enlightened, literally.
Now you may have noticed in that experiment that the light on the bottom of the box was not in the shape of slits, rather they were more kind of round blobs. And I want to know why that is. Can you write an answer for me in the comment section? And I'll give you a hint. One of the videos I've linked kind of is suggestive of the answer. So convincing were the results of Young's double slit experiment that the scientific community concluded that light must be a wave.